So let's just go ahead and do a sketch first. And because I don't know what color it's for what, so I will just draw everything black first. So this right here, 1 over 4x. So this is a line like this. This is y equals 1 over 4x. Next, 2x, so slope is higher, so it looks like this. Y equals 2x. Now, 4 over x is a higher hyperbola like this. And then 1 over x is the smaller one. Actually, let me put on y equals 4 over x, and then 1 over x. It will look like this. Look at this thing. This is the region that we are talking about. This is the region that we're talking about. How do we find the area of this region? Just think about in Calc 1. How do we set up integrals? If we do horizontal rectangles, changes. Vertical rectangles, changes. So we are totally stuck on this. Don't worry, there's something called the Jacobian that's going to help us. And the purpose of the Jacobian is to help us to change this crazy region to a much better region. So I have all this equation written in terms of y being isolated, but if we don't do that, then you can see this right here, it's the same as saying y over x is equal to 1 over 4, and then divide the x on both sides, y over x is equal to 2, and then multiply the x on both sides, so xy equals 4, and then lastly xy equals 1. Guess what? This similar, this similar. So what we are going to do is I'm going to call this to be, let's just say u. I will say that u equal y over x. Yeah, and then right here I will just call this right here to be v equals xy. So this right here will be the change of variable that we have. So now after we pick this right here, what we will have to do is we will have to get x and y in terms of u and v. So how do we do that? Just solve system of equations. Multiply the x on both sides, so we know this right here tells us y equals x times u. And then I will just put this right here for that. So that will give us v equals x times y, which is xu, which is x squared u. Yes, v equals x squared u. X squared equals v over u, divide the u on both sides, and then we see that x is equal to, I'll just take the square root of v over square root of u. Everything's positive, so don't worry about the domain and all that stuff, don't worry. Yeah. So that's that, and then x is this, so I'll put it here, so this means y equals square root of v over square root of u times u, and this and that can be reduced, so this right here tells us y equals square root of v and u. What we want to do next is we want this integral to be in terms of u and v after the transformation. Then to make that happen, we have to get the so-called Jacobian. Okay, this right here, use the determinant notation. Now this time, the bar is not the absolute value, it's just a determinant. So we will do partial x, partial u, and then partial x, partial v, and then partial y, partial u, partial y, partial v. And again, this is the determinant notation. To make this easier to differentiate, I'm going to write the following. I will write this as a polar notation, which is u to the negative 1/2, and then v to the positive 1/2. And then for the y, I will write it as u going first, positive 1/2, and then positive 1/2. And hope for the best. Here we go. Partial x with respect to u. So look at this, a differentiate, put the power to the front, so we have negative 1 over 2, and then minus 1, so we have u to the negative 3 over 2, and this thing just stays, so like that. Now do this with respect to v, so put the 1/2 to the front, so we have 1/2, this thing stays, v v and then minus 1, so minus that. And then now do this with respect to u. We have 1/2 u negative 1/2, and this thing stays. And now do this thing with respect to v, 1/2 u to the 1/2, and then v to the negative 1/2. Okay, this times this, negative, negative, no, negative positive, so it's negative 1/4. Yeah, this v cancel. U to the negative 3/2 times u to the 1/2 is u to the negative 1. Okay, u to the negative 1. And then we do this times that, but it's a minus in between. 1/2 is 1/4. This and that is u to the negative 1. And this and that, they cancel, so we have this. And we can combine them. Negative 1/4 minus 1/4 is negative 1/2. And then we have u to the negative 1. Yes. You think we're done? No, we are not. This is just a Jacobian. It's just... So what exactly are we doing, right? Yeah. Don't worry. Now, integral, still that function e, but xy, it's like the v. So we have negative v, and then over 2. I'm going to just put down du dv. Originally, it's like supposed to be like dx dy dy dx. But no. Du dv, much better. But we also need this thing. And remember, this is just a Jacobian. We need the absolute value, and then negative 1/2, and we have u to the negative 1. So that's the dy dx part. And if you set it up like this, then u goes first. So u starts with what? Our u is this. So it goes from 1/4 to 2. So I would just say u goes from 1/4 to 2. And then v, you see, v is xy, so it goes from 1 to 4. So v goes from 1 to 4. Oh, by the way, that will just make this positive, and then u goes from this to that, so it's positive anyway, so don't worry about the absolute value of u to a negative 1. You see, this thing has no u here, so we can actually break them apart into 2 integrals. So I'm going to do this one first. So v is equal to 1 to 4, and now I'll just look at e to the negative v over 2 dv. And then the other one, I will just multiply it with u going from 1/4 to 2. And I'll just look at absolute value of 1/2 is just absolute value of negative 1/2 just 1/2, and then we really don't need to worry about the absolute value for, because 1/4 to 2 du. And the good thing is, if you integrate this, integrate that, multiply it, you get the answer. Integrate this, we have e to the negative v over 2, but we will have to divide it by the derivative of this, which is divided by negative 1/2, which is the same as multiplied by negative 2. And then we go from 1 to 4. Let's focus on this right here first. So put 4 in here, we get negative 2e, that's negative 2, and then we subtract, but that's a negative, so it becomes plus. Put a 1 in here, we get 2e to the negative 1/2. Yeah, that's that. This thing, 1/2 ln u, and we go from 1/4, that's ready as 2 to the negative 2, and then 2 is just 2. Put 2 in here, we get 1/2 ln 2, and then just minus 1/2 ln 2 to the negative 2. But you see, this negative 2 can go to the front. So that's that. And I can do the blue part a little bit more. This is 1/2 ln 2 becomes plus, and that's gone. And then we have just ln 2. which is 3 over 2 ln 2. So this is the blue part. And then this part is still this cancel. And then let's put a 3 back here to the power. So ladies and gentlemen, we get negative e to the negative 2 plus e to the negative 1/2 times ln 8.